Hello, scholars. So let's take a look at 2-3 Extrema and End Behavior today. Our learning targets, I'm learning to identify the end behavior of graphs. I'm learning to identify extrema of functions. So when we look at end behavior, we're actually looking at the behavior of a graph as the value of x approaches positive infinity or negative infinity. And so when we take a look, we're actually going to look at the right side of the graph first. So at the right side, of the coordinate plane, x is increasing toward infinity. And we actually write that as x, right arrow, positive infinity. But when we take a look at the left-hand side, so at the left side, of the coordinate plane, x is actually decreasing toward negative infinity. And so when we take a look at that, it goes x, we have the arrow going, and then we have negative infinity. And that's how we'll write as it approaches negative infinity. All right, so let's continue looking at some of this end behavior. Here we have 3 different examples of graphs. They all look different. However, all of their end behaviors are the same. So when we take a look, we have the right-hand side of our x-axis right here. And so as x is increasing on this side, what's happening to this y value? It is also increasing. So we say as x goes towards infinity, positive infinity, y is also going up. And because we have that arrow, it's also approaching positive infinity. All right, but now we have this other side of our x-axis. And so here we say as x is going or approaching negative infinity, let's take a look at our y. Here's our y value. It's going down. So y is also approaching negative infinity. Let's take a look at this next example right here. We have the positive x. So as x approaches positive infinity, what's happening to our y? So let's take a look at this side of our coordinate plane, the right-hand side. Our y is actually still going in that upward direction. So y is also approaching positive infinity. And now if we take a look at the left-hand side of our coordinate plane, when x is approaching negative infinity, let's see what y is doing. It's also approaching negative infinity. So it would say, hey, as x approaches we're on negative infinity now. As x approaches negative infinity, y also approaches negative infinity. Next example, take a look at that right-hand side of our graph. Here's our x-axis. As x is approaching a positive infinity, what's happening to our y? Our graph is actually still increasing itself. So once again, we have for the 3rd time in a row, as x approaches positive infinity, y is also approaching positive infinity. And so we're going to take a look at what happens when x approaches negative infinity. And when we take a look at that left-hand side of our graph, we see that our graph is going down, so it's also approaching negative infinity. So that says, hey, your graph of y is also approaching negative infinity. So here we have 3 different types of graphs. And what you'll notice, they all 3 look different, but they all still had the same end behavior. So we really just have to pay attention to what's happening. All right, let's go on. So here we have to describe the end behavior once again. So we have the left-hand side and our right-hand side. So on our right-hand side of our graph, what is happening? So as x approaches positive infinity, is y going up or down? It's going down. It is decreasing. So it is approaching negative infinity. All right, so let's take a look at that left-hand side of our x-axis. All right, here x is decreasing. So we are going towards negative infinity. So as x approaches negative infinity, is y increasing or decreasing? And y is actually increasing. So y approaches positive infinity. All right, for our next example, let's take a look at our graph. So here is the right-hand side where x is positive. So let's take a look. So as x approaches positive infinity, what's happening to y? Well, nothing really. It's kind of just flat. And remember, we actually call that a constant function. And with constant functions, we have a value in which they are constant. And if we look at this y-axis, we have 1, 2, 3, 4. This is 4 on our y-axis. So as x approaches positive infinity, y is not changing. So we say, hey, y is not changing, and it's just going to stay at the value of 4. And conversely, when we take a look at that left-hand side of our x-axis, as x approaches negative infinity, y is also still constant and approaching the value of 4. So when we take a look at end behavior, one of the big things you need to know is to determine end behavior, do not focus on the values closer to the origin. Instead, focus on the graphs of the behaviors at the end of the graph. So we're just looking at the ends. So in essence, 2 graphs can look entirely different but still have that same end behavior. So when we take a look at these 2, as x approaches infinity, y is also approaching positive infinity. And when we take a look at as x approaches negative infinity, that left-hand side, y is still approaching positive infinity. And so when we look at this absolute value function right here, the same thing happens. As x is increasing, y is also increasing. So as x approaches positive infinity, y approaches positive infinity. And as x approaches negative infinity, on this side, the left-hand side, y is still increasing. So we still put y approaches positive infinity. These graphs look entirely different, yet their end behaviors are still the same, and that's all right. So let's continue describing some end behaviors. If you can't tell, this is a very important concept, which is why we're doing quite a few examples. So as x approaches positive infinity, what does y approach? So here we have the right-hand side of our coordinate plane. We're going positive, but y is going that negative direction. So we say y approaches negative infinity. All right, and then we have y. Why do I keep doing that? As x approaches negative infinity, that left-hand side of our coordinate plane, let's take a look at what happens down here. Our y is also approaching negative infinity. And that's it for that example. So let's take a look at this one. As x approaches positive infinity. So here's our positive side. Remember, we're looking at the ends of our graph. So we're going to look down here. It is going down, so y approaches negative infinity. And so as x approaches negative infinity, the left-hand side, we can see that y is up here. It is increasing, so y approaches positive infinity. All right, so we've talked about end behaviors. Let's talk about what we call extrema of functions. Extrema, there's a lot about extrema, so let's just jump into it. So relative minimum, or relative maximum first, is a point on the graph of a function where no other nearby points have a greater y coordinate. So when we look at extrema, we're really going to be looking at our x's and our y's. And relative maximum is a form of extrema. And we're looking at the highest y values of our graph that we can estimate. And so if we have a relative maximum, we also have a relative minimum. And that is a point on the graph of a function where no other nearby points have a lesser y coordinate. And now we have turning points. And if you think turning points are where your graph turns, you're absolutely correct. But turning points include your relative maxima and minima and it is aka where the graph switches directions. So extrema actually references all of those, the relative maximum, the relative minimum, and the turning points. And we just call it extrema. And when we say extrema, we need to know that we're talking about all three of those. So refers to relative maximum, or maxima, because plural, the relative minima, and turning points. All right, going on. Let's take a look at some examples of extrema. Here we have a table and we have a graph. So the table and graph below have extrema. And we need to estimate the zeros, then estimate the coordinates at which the relative maxima and minima occur. So let's first take a look at our table. Now, a minimum or a maximum is going to happen when we switch directions. So let's take a look. We go from positive 7 to positive 2 up to positive 3. Because we have a change in direction, we went From 7, we went down to 2, and from 2, we went up to 3. This right here indicates a relative minimum because we had to go back up. And then from 3, we went to -2. So we're going back down, and because we went down, it forms a peak and becomes a relative max. And then we keep going down again. And if you notice, from -1 to 42, I went back up. And because I went back up, we have another relative min. And notice, we went from a negative to a positive, and because we went from a negative y to a positive y, we're going to have a 0 in between these two values. And that's because it crosses the y-axis. If we take a look over here, we have a 0 right here. So this is our x-axis right here, where it crosses. So here we've identified 2 relative mins, 1 relative max, where it crosses the x-axis and where it crosses the y-axis. Now if we go over here, we should see those same reference points. So right here, because it dips down and makes a valley, we call this a relative min. And if you look, it's kind of at, what, 1.5-ish? -1.5-ish. So that makes sense. And then we have a max here, so relative max. Another min here. And then we have zeros. Well, this is where a y-coordinate or a y-intercept. And then we have 2 x-intercepts. So this is how you would identify it from the graph, and here is how you would identify it from the table. I like identifying it from the graphs a lot better. All right, so we have one further example that we need to talk about. And it says, food prices cost, the cost of an orange changes over the course of the year, as shown in the table for each month starting in January, and in the graph of cost over time as a function. Use the table and graph to estimate the extrema for this function, then explain the extrema in the context of the situation. So we have this huge table, and we have this huge graph. Let's first identify our relative maximums, and let's go ahead, I'll do that in blue, so relative max. And it looks like we'll have a few of them, so relative maxima. All right, so going up, we don't have a change in direction yet. We're still going up. We're still going up. Here we have an up. Before then we go down, and we have another up. So these two values are relative maximums. And so we have a relative maxima at 3, at x equals 3, and at x equals 5. Now let's take a look for a relative minima. We're going up, going up. We change direction. So here's one, and then here's one. Notice this isn't a real change in direction because it just kind of flattens. And these are our relative minima. So when we make a list of our relative minima, we have them at x equals 4 and x equals 10. So when we explain the extrema in the context of the situation, what's happening at the relative maxima? At the relative maxima, the oranges are the most expensive. And at the minima, especially this one, the oranges are the least expensive at that time. So, though in April, the oranges were still 90 cents, they were still cheaper than either of the months on the side of them. But they were the cheapest in October at 40 cents. All right. So that's the end of today's video. If y'all have questions, please let me know, especially when you're working on your assignments. I'm going to set up some office hours. We can even do some one-on-ones. So let me know, y'all. Thank you.